back with that Mesa base strategy, 888. I don't have the schematic for this yet. I do have the schematic for the similar base Prodigy. And there's a service update for the Prodigy. And it would not surprise me if there's a similar one for this strategy. But it's not exactly the same in the area where the service update is. So there's a hum and a noise with nothing plugged into the unit. And right now I've got the masters off and the channel volume off. And I'm going to go into the effects return, first of all, to see if I can isolate the problem to the preamp or after the effects loop. And that way I can hopefully get closer to finding it. So let's plug in with instrument with the volume off into the effects return. Let's see if there's a change. All right, there's no difference. I'm gonna turn the master up. So there is a hum in the output. The hum and buzz is all in the output. Let me consult the schematic real quick. Okay, so let me find my little pointer, especially with this thing with 600 plus volts in it. Definitely want to use the pointer. So the signal goes in to V1, which I think is this one, and the whole bunch of op-amp stuff. And then it has the EQ stuff. And from there it goes to the effects loop. From the effects loop it goes to the master volume. The master volume is not affecting the noise we have. After the master volume it goes to V2, which is the first stage of the splitter driver. And from there, the two plates of V2 go to these two IRF 820s, which are buffering. Let's just say that for ease of concept, so that it can handle a lot of current. It's like a cathode follower attached to the plates of V2. And from there it goes to the V3, A and B. It's just two additional gain stages. Okay. So you have current capability from the IRF 820s, and you've got voltage from V3, and then it goes to the power tubes. So V2 is doing the actual splitting in terms of the inverting of phase, and then the IRF 820s. So the first thing I want to do is pull V2 to see if that affects the sound. V2 is a Mesa labeled Sovtech 12AX7A. Let's take it out of standby. All right, that's promising. The noise is gone. So if we're really lucky, it'll be a bad tube in V2. Let me put a different tube in there. Let me tell you, it's a lot of fun trying to fit your hand into a narrow space between some hot KT88s. So we've got a Mullard reissue 12AX7 in V2. Let's take it out of standby. Okay, same issue. So where is the hum coming from? Let me take a look at the circuit now. Okay, if this is like the Prodigy, I know what rough voltages I should expect to measure at V2. So let's see if this correlates. I want to make sure that it's biasing correctly. $138, 130. That's about 40 volts lower than it says I should get. And about half what I should be getting at the cathode. So let me measure some resistors attached to that. Let me power it off first before I play around with resistors, because the node feeding that is supposed to be at 428 volts. While I've got all of your attention here, that is node C, which I believe is a node on the Prodigy, which is affected by a service update. Let's see here. Yeah, R106 in the Prodigy was a 10K half watt, which they updated in later revisions to a 10K 3 watt. Now that's the Prodigy, but that is powering this B plus node. And if that is a faulty resistor, that could give us this problem. The issue being that the service update I have for the Prodigy model has R106 right here, and the board layout is different here. And this is not a 10K half watt. This is a 15K 3/4 watt. I think I see 106 beneath it. Mesa always has the part numbers beneath the component. But I don't know whether this is actually R106, whether they just use a 15K in this model versus the 10K in the Prodigy. So the first thing I want to do is check continuity. The node which is supplying V2's plates, V3's plates, and the B plus going to the IRF 820s. So if that one resistor is the fault, that would be nice to know. So let me go to ohms, make sure this thing is powered off. All right, so one end of potential R106 and pin 150, oops, that's why I have it powered off. 157, 150, 160, and there should be similar here with 110. This one's climbing up. Should be 100K. Oh, I have my measure. I started from the wrong pin. Sorry. Yeah, 113. All right, so this right here is definitely the plate, the dropping resistor from stage to stage. And I can take this out, this little 3/4 watt. The issue is I cannot fit a 10 watt resistor in here, or even a 5 watt. So I need to hope that one end of one of these Zehners is electronically equivalent to this side. Let me get my pointer. This is the supply from the rest of the preceding part of the power supply. And I can't fit a resistor here. In their service note on the Prodigy, they show a resistor going from here to over here on the Zehners, so they can have a large resistor. And I need to see which of any of these would be functionally equivalent to this point right here. So let me check some things. All right, mystery begins to unravel. These three resistors here are not 15K resistors. If I squint, I can see that these three are in parallel with each other. So instead of one half watt 10K or the one 3 watt 10K, they have three 3/4 watt resistors in K that make add up in parallel to be 15K, and that is tied coming from this node here at ZD2. And this string of Zehners here is a dropper for the screen supply. Because why just Mesa loves to do weird things with high voltage, and so this is where they're doing that with this string of Zehners, every one of which should be mounted off the board higher. So it's not all that likely that any one of these three resistors would be bad in parallel with each other. They're all going to share the wattage to a degree. But I've had many of this kind of resistor fail in a Mesa. These little 3/4 watt Vichets. I don't use them in my own stuff because I've had too many failures with them. They like to fail in Mesas. They like to fail as plates and high value cathodes, especially in following stages. So R60 and R59 are possible points of failure. Given that the noise goes away when V2B is pulled, it's also possible that we have a leakage with C42A and C42, if I can find them on here, with the 47K to ground from the grid. Sorry to be talking out loud. There's just a lot of stuff that it potentially could be on these. Let me disconnect this EQ section ribbon cable and get it out of my way, because it's hopefully not going to be necessary for troubleshooting power supply woes. This thing is so much fun. Turns out this ribbon cable has to be put in place, otherwise the relay for the low, medium, high power switch defaults to the lowest power, and it's harder to hear things. I've gone through a lot of stuff related to the plate and cathode of V2. It took me a while to find it on the board because there's no layout available for these, and you can't see the traces. And so, like, the cathode for V2 is actually over here, and the plates are actually underneath these caps here, and some of the resistors going to these IRF 820s. And it could be one of the resistors beneath these caps, but I did get a hold of the schematic finally for this Strategy 88 to compare to the, and compared it to the Prodigy, and I confirmed that those are 347Ks in parallel to give me 15K there, and a lot of things I had puzzled out already. And the thing that's common to both the Prodigy and the Strategy, which is my next line of thinking, is that V2, which is the tube which is introducing the noise into the circuit, is the only tube in this amp of the three preamp tubes that has a DC power supply. If I pull V2, all that noise goes away. And I'm suspicious of its 12-volt power supply. Now, the regulator here, it's a 12-volt regulator. It's got a 2.2K microfarad cap in front of it. It's got a 1K microfarad after it, I think. Let me look at the schematic real quick. Yeah, it's got a 1K microfarad and a 1 microfarad after it in parallel. And then there's another, I guess that's it. And the only things, according to the schematic, that this 12 volts are powering are the front panel LEDs and the heaters for V2. 2.2K is very, very low filtering for a tube heater, the DC supply. I would expect more along the lines of 10K than 2K. Could also be a little bit of additional regulation, a little bit more filtering on the actual regulated part. But given that I have access to the incoming 20-something volts here and the outgoing 12 volts here, and I've got this big, nice ground plane here, I'm going to find some suitable caps, like 10,000 microfarad, 35 volts, 1,000 microfarad, and just touch them to here and here and see if that noise changes. This is the frustrating thing about Mesas and other amps like this. We know that there's a 12-volt DC supply that's only used for this tube. This tube is the source of the noise. If I pull this tube, all the noise goes away. The voltages are within spec. I doubt there's a problem with these 347Ks feeding that node. That's the next thing I'll look at, just in case one of them is bad. It could be the plate resistors for this. It could be the resistors going from this to the IRF 820s. Those resistors are buried underneath these caps. It's very hard to access, and I don't want to do that work if it's not necessary. That's why these amps are so expensive to repair. And it just takes a long time to find. Like the cathode resistor for this tube stage, it's over here. Is not anything you can easily find. You look all around, which one of these is it? I just happened to stumble on it. It's not a logical place to put a cathode resistor. I need to see if that is a bypass cap for that cathode. It's not shown on the schematic, but these tantalums get faulty. So that's the next thing. Let me check that real fast. Well, that tantalum, even though it's right next to that cathode resistor, is not across that. That's early in the stage. V3 has got some tantalums here on on its two cathodes, and that could be it. But the thing I just discovered is that these two caps are feeding the input of V2. From the master volume, it goes to a relay, which mutes the next stage when it's in one position, and then goes to the input of these two caps in parallel with each other, then to the grid of V2B. The V2A grid is shorted out to ground. That's how it inverts as part of the circuit. But when I tap on these two caps, very minor on that one, much more audible on this one. These two caps should be identical. And these are 400 volt caps because it's a Mesa. There shouldn't be anything close to 400 volts on that cap because it's just blocking the grid here on V2, which should be fairly negligible as far as DC, even though it's referenced to a negative voltage. What is that in reference? Let's see. I know that the other side of that cathode is at negative 62. What are we getting at that grid? This may be noisy. Let's see. Always fun playing around with this stuff. That shows. That's the right pin. Shows no voltage there. So that's as it should be. So that's at 0 voltage, and the cathode is actually much lower in reference. It's an odd circuit, but I suspect it might be this capacitor. And as these two capacitors are inexpensive and more easily accessed than a lot of the other stuff in the amp, let me do a Hail Mary and try those. All right, I'm feeling like a genius. So instead of two 400 volt, 22 microfarad, nanofarad caps together, 0.022s in parallel, I use one 630 volt, 0.047, 47 nanofarad cap, electronically equivalent, much better design. I don't know why they would run those in parallel. And that hum is down. It's almost gone. But there is white noise. And now we've got white noise, but not the hum. So we're making progress. So it's good to have one problem gone. White noise is typically a resistor. It could be any number of resistors, including the ones hidden underneath these caps. But it could also be a bad tube in V3. And it could also be this tube in V2, because that's not the one that was in there when it came in originally. So I'm going to try some different tubes before I dive in any more. But it's really nice to get that hum out of the way at least. I was hoping just one thing was causing all the problems, but that's unlikely when you have an amp with this many components built to this level of quality. All right, move some tubes around, put some different tubes in various spots. And the hum seems to be at a normal level for such a big amp. Let's see what it's sounding like now. Going into the effects return first. That was just bass directly into the phase inverter. Let's see, let me flatten out all the tone controls. We'll go into the input on the other side. Let's see. And EQ flat. Let's see what all the controls do. That's where I started. That was the voice control. I find position 5 to be nice. Let's see what the treble, middle, and bass do. So bass. Mids. The mids are kind of centered pretty low. And treble. Let's see, I think there's a bright setting on this. That's pad. Let's see, the EQ is... I got some rushing water noise coming back. Is that all in the EQ? No. You can still see a little bit of red on these two. This pair of tubes out of this quad just started to red plate, this one and this one. And I think that's where that rushing water that started up at the end was. And all of a sudden the volume began to attenuate. So, all right, preamp phase inverter issues resolved. Now we got to see what's going wrong with these damn tubes. What a wonderful, wonderful amp this is. All right, the two tubes that were red plating were this one and this one. And these are the two that were the sockets, and the tubes burned in the past and the traces were all burned. And I suspect that those sockets just have some carbon causing them to be a little conductive. Even though it measured okay with the meter, that was, measuring with the meter. There's no current to a meter, and it's not hot. But those are the only 2 tubes out of the 8 that were doing it. So I think it's just time to replace these 2 sockets with some more ceramics, and I'll take measurements. I think they're using the ruby ones. I'll find out, and I'll look and see if there might be room to upgrade to the Beltons. But either way, I'm not going to tilt any more windmills until those sockets are changed out, because I just don't damn trust it.